I'm sure all of you saw the email that next semester is going to be mostly online too. So hopefully you're kind of used to taking your classes online now. All right, so we're going to get started. So today we're going to continue on with arrays. Going to do a little review like we do every time. So slides updated late last night, and your second homework that was posted on Monday. So if we go to the homework, so I uploaded, what I called the Canvas version. So basically I made the homework where it's kind of like the quizzes that we have. So I have a little input here for each question, and then you're just going to answer it in the text box here. Let me preview it. Okay, so you're going to answer each question just in this text box, and that should be pretty self-explanatory. If you have any questions, let me know. The formatting for this on Canvas kind of sucks, to be honest. I mean, it's okay, but like these brackets for the matrices, they look kind of weird. So if you want to see better formatting, I couldn't link it on the actual homework page, but you can click on week 4, and then I also have a PDF right here. And this has much better formatting or something else. And I think this is beneficial for all of you to just know too. If you want to look at, oh, I need to make this available. So let me leave student view. So I'll make this available later, this page, but you can click on files. And then you can see all the files that I uploaded for the course. So I have folders here for homework solutions, lectures, quiz solutions. And then you can, more easily access stuff like this. So here's the homework. So I'm going to make this page available later on too. All right, so homework is due on Monday, this coming Monday by 11:59 p.m. And then our second quiz, that's this coming Wednesday. And so not today, but next Wednesday. And just like the first quiz, that'll be towards the end of class. Okay, so we're going to do some quick review here. So I want you to make this multi-dimensional array. So we have 3 layers here. So the first layer is going to be matrix A, second layer matrix B, third layer matrix C. And then I want you to write some code to specify the second row of layer 1. And then you're going to create a row vector composed of the third row and the third column of layer 2. And then create a submatrix of, this matrix here. So that's from layer 3 in this matrix right here. Okay, so I'll give you, maybe, I don't know, 3 to 5 minutes to work on this. Kind of get your brain in the mode for Matlab. you can continue to work on it. I'm just going to define the three matrices here. All right, so we got a fair amount of you that are done with the exercise, so we're going to go ahead and go over it. Also, for the homework, some of the stuff that's in the homework we're going to be going over how to do today. I'm hoping we can get to array division because that is on the homework. But if not, you might need to look at the slides, a few of them, to complete it. But if we don't get to that today, so array division, or basically whatever we don't get to today in this lecture, that won't be on the quiz. But you might need to look at some of the slides for the homework. Okay, so let's do this right now. So we defined all of our matrices here. And now we need to use the cat command to make this multi-dimensional array. So what did I call it? Wait, let's do something new. So I'll call it multi. So I'm just making this variable called multi equals cat. We want a dimension of 3 because we want to make this multi-dimensional array. And then we're going to put our arrays in here. Let's actually look at the output here. Okay, so there's the multi-dimensional array. I'm just going to clear it just so I have some more space. Okay, so now we want to write some code to specify the second row of layer 1. So I'm going to make another variable here, just call it second, doesn't matter. And okay, so we want the second row of layer 1. So I'm going to type in multi. Okay, because I'm going to reference that multi-dimensional array, and I called it multi. And then we want the second row, so we're going to put a 2. And then we want to look at all of the columns in that row. So, we're in row 2. Now I want all of those values right here. So that's why we have the column. Then I'll put a comma, and then I'll put a 1, because I want to look at layer 1. And then we get the second row of layer 1. All right, so now we want to create a row vector composed of the third row and the third column of layer 2. So I want a row vector, so I want to have, a vector of 66, 5, 7. And then we're going to have to transpose this column vector here. So then we basically append the values 18, 7, and 7. So I'll call this row. So here I'm going to have to use brackets, right? Because I want to define a row vector. So I need to use brackets. So I'll type in multi, because we want to reference that multi-dimensional array. Okay, third row. So we have the third row here. We want to take all those values, and we are in the second layer. And then we can put a comma, or we could put a space. And we're going to do multi. And now we want all of the values in the third column of the second matrix, or the second layer. And now we have to transpose that because we want to append this column vector to a row vector where we want to make a new a new row vector in total. So there's kind of a lot going on here. What did I mess up?
There's a missing comma between the colon and 2.
Yeah, thank you. All right, there we go. Thanks for pointing that out. All right, so then we get that row vector right here. So we have 66, 5, 7. And then we transposed our column vectors. We have 18, 7, and 7. Okay, I'm going to clear everything again, just to have some space. Now we need to create a submatrix of 34, 9, 0, and I put -2. So I think I might have intended to put a -2 up here. So sorry about that, but it doesn't matter. I just want you to create this submatrix right here. Okay, so I'll just call this sub. Then we're going to reference that multi-dimensional array. So here I need to have the first row and the second row of layer 3. So I'll do the first row, and then I'll use a colon operator and put in 2. So that's going to say look at rows 1 and 2. And now I need to do columns 2 to 3. Okay, so right now this code is going to look at rows 1 and 2 and columns 2 and 3 for each layer, but I want to look at the third layer. So I'm going to put comma 3, and then we get that little submatrix. That's the term I'm using here. Okay, so any questions on that? I think this is going to be a good quiz question, something like this. So make sure you know how to do it.
Professor, you can, instead of doing like one individual, you could do multiple rows all in one go.
Yeah, just like we did for that last part there.
Okay.
So let's do a different example where we take multiple rows. So I can do, let's call this another. So if I want to look at, let's say all 3, maybe not all 3, but we'll do the first 2 rows of layer 2. So for matrix B. So we'll do multi. We'll do the last 2 since we just did the first 2 rows. So we'll do, we want to look at rows 2 to 3 for matrix B. So we want to output the values 9, 8, 7, and 66, 5, 7. So we'll do rows 2 to 3. That's why we're using that colon operator since we want a range. So we're doing rows 2, colon to 3. That'll give us rows 2 to 3. And then I want to have all of those values for those rows. So this comma, colon, that means take all of those columns basically. So we have column 1, column 2, and column 3. And then we want to specify that second layer. Okay, and then we get all of those values for rows 2 and 3 for layer 2. Okay, any other questions?
How is it column 1, 2, and 3 if you only put 2 and 3?
Say that again?
You said it's column 1, 2, and 3.
Mm-hmm.
How is it 1, 2, and 3 if you only put 2 and 3 right
So
there?
this 2 and 3, that's for the rows. So that's taking rows 2 and 3 here. And then I put a comma and then the colon, that means take all of the columns in those rows. So like, remember for a matrix, we define that by m by n. So the first value we have m, that's for the rows, and then n, that's for the columns. Does that make sense?
Yeah, thank you.
Okay, yeah. So I'm just going to go over that again one more time just so we can kind of reiterate it and make sure all of you understand that. So in this line of code for another, my first, we'll say range here, or argument. So the argument 2 colon 3, that means the rows 2 to 3. So that's row 2 right here, and then row 3 right here. And then I put a comma. So now we want to look at the columns. So now we're specifying what columns to take. So the colon operator for this, specifying the columns, that means take all of the columns. So that's column 1, column 2, and column 3. since we're looking at just rows 2 to 3, we're going to get all these values here, 9, 8, and 7, 66, 5, and 7. Okay, so I think this is a problem on the homework too, something like this. So you might want to, reference this slide. Okay. Okay, so now we're going to talk about scalar division with arrays. So last time we did some pretty basic stuff. Let's actually, I'm not going to have any exercises for it, but we'll just quickly, go over it. So we had a scalar vector multiplication. So we had some vector and we multiplied that vector by a scalar. So in this slide, we had a vector from 2 to 8, and then we multiplied that vector by 2, and each value in that vector was multiplied by 2. So we also did that for a matrix. So we had a matrix and multiplied it by a scalar. Each element in that matrix was multiplied by 2. Then we did subtraction and addition with a vector. Again, that was just with a scalar. So I had, some vector here, and then I subtracted it by a scalar 2. And each element in this vector was subtracted by 2. Again, same thing for a matrix. It's basically going to work the same. It's just going to do the operation on each element. So you see up top here, I'm using the term array addition and subtraction. In Matlab, an array operation, whether it's array addition and subtraction or array multiplication or array division, you can also call that element by element. So I think I said that at some point. Yeah, right here. So on this slide, slide 49, I say array operations / element by element operations. Okay, and then we can do array operations for addition and subtraction between vectors as well. So before we just did it for a vector and a scalar, but we can also do it with vectors. So in this case, we have vectors R and S, and I wanted to add those two vectors. So if we look at it like this, it's a lot easier to see. So the index for each vector, they're going to have an operation between the two. So for this index of 1 for each vector, we basically have 3 plus 2, and that's going to give us 5. Then we go to the next index, index 2, and we have 4 plus 8, that equals 12. Then we go to the next index, and we have 10 plus 4, 14. Then the last index, 22 plus 10, is 32. So far I think all of this is pretty intuitive, where you can kind of, just look at it at a glance and know what's going to happen. And you can do it for subtraction as well. And then we talked about, do the dimensions need to be the same? They do have to be the same. So if we wanted to do, if we had this vector A and this vector B, and we wanted to do vector B subtracted by vector A, those dimensions have to be the same. So we kind of tricked Matlab into basically saying that they were the same length by just adding a 0 at the end of vector A. So then we could do that operation. I think last time, I don't know if it was on, I think it was on this slide, I talked about how at some point we could create an array full of zeros and we could build into that array. So this is just kind of an aside right now. You're not going to be tested on this right now or anything like that. But if I make this matrix zeros 5, 5, this gives us a 5 by 5 matrix, and it's full of zeros. So this will be useful. Now I said that we could build, we can kind of like fill in this array, and that is true to an extent, but it's a little different than I was talking about last class. So we do this often with for loops, and basically, so we specify this operation here, and then we use a for loop, but we fill in this entire matrix. So we need to fill it in entirely and not just, row by row or column by column. So again, this is just an aside. I kind of briefly talked about it last time. and I said I would cover it today. So it's not anything to worry about right now. We're going to get into this for chapter 4, but I just wanted to mention that really quick. Okay, so then we can also do array addition and subtraction between matrices. So just like with our vectors, it's going to work basically the same as we would expect. So we have matrix A here and we have matrix B. So I'll just go through this first row. So I'm doing matrix A subtracted by matrix B. So it's, in the first index here. Index 1, we have 5 minus 2, that equals 3. Go on the next index, 4 minus 4 is 0. Next one, 3 minus 10 is negative 7. Okay, and those dimensions, they need to be the same once again. Okay, and then that took us to our exercise at the end of the last class. And takes us to here today. So, scalar division. Oh, sorry, there was a question. Can we multiply or divide matrix by matrix? Yeah, so that's what we're going to be doing today for pretty much this entire class. Okay, so scalar division with arrays. So we'll talk about that first. So I can define some vector here. So we'll do what I have on the slides. So I'll define this vector 4, 10, negative 8, and 9. And then I can use that vector and I can divide it by 2. And it's going to divide each element in this vector by 2. So we have 4 divided by 2 is 2. 10 divided by 2 is 5. Negative 8 divided by 2 is negative 4. 9 divided by 2 is 4.5. If we were going to flip the order of this and do 2 divided by the vector u, now it's not going to work. It's saying that our matrix dimensions, they must agree. So here the order does matter. So if we wanted to do this though, if we wanted to divide each element in our array, or do 2 divided by each element in the array, we have to do array division or element by element division. So for that, we'd have to put a period and then a / and then u. And now it's doing it element by element. So I'm bringing this up now, but we're going to go into a lot more depth on this later today. Okay, so scalar division with matrices. So this is going to basically work the same as I just showed you right now for vectors. So we can define a matrix A here. We'll do 2, 4, 6. So that's our first row. And 8, 10, 12. Okay, there's our matrix. So if I want to divide each element in that matrix by 2, I'll do matrix A, then divide it by 2. And then that'll divide each element in that array by 2. So we have 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. And then just like with the vector that we just saw, if I do 2 divided by A, we're going to get an error because our dimensions don't agree. So here, because I put a 2 first, it's thinking that I'm doing a matrix operation here. So it thinks I'm trying to do matrix division. Again, we'll go into more depth on this later today. So, but if I wanted to do this, I would have to do an element by element operation. So to do that, you put that period and then whatever operation you want to do. And then it would do 2 divided by each element in A. Okay, so now let's kind of get started here. So we talked about before briefly element by element operations. So we did that last class. So that was this stuff here. We didn't explicitly state that it was element by element. So here we had a vector and we did 2 times that vector. And this was an element by element operation because it acted on each element, but we didn't have to explicitly state it. So for some things in Matlab like this operation here, we don't have to explicitly state it, but because it's operating on each element, it's still considered an element by element operation. So we did that, and then now we're going to talk about matrix operations. So from last class, we talked about how Matlab has two different definitions for arithmetic operations. So we have array operations and matrix operations. So again, we just briefly went over array operations. Now we're going to go over matrix operations. So this is more the stuff that you do in math class. So if you took linear algebra, you're going to be familiar with this. And if not, that's okay. We're going to go over it a bit, but you might need to look at the slides in more depth to just kind of understand the math behind it. Okay, so now we're going to start off with a matrix operation. So we're going to do matrix addition and subtraction. And you'll see here from my comments that matrix addition and subtraction, it's going to work the exact same as an element by element or array addition and subtraction. So let's define a matrix A. We'll do 9, 8, and 6, 8. And then a matrix B, 3, 4, 2, 3. Okay, so if we add these arrays, we'll do A plus B. I subtracted it in the slide, doesn't matter, let's add them. Then it's doing 9 plus 3 is 12. So we're looking at the first position or index in each array. So for matrix A, that's 9. For matrix B, that's 3. So it's going, okay, let's look at first position and let's add those two values. So 9 plus 3 is 12. Then it goes to that second value. So we have 8 plus 4 is 12. Then it goes to the third value, 6 plus 2 is 8. Then it goes to the fourth value, 8 plus 3 is 11. And we could do B plus A. Well, that's going to be the same. All right, so any questions so far? I think maybe, like if I'm you right now, I'm a little confused on the differences of element by element operations and matrix operations, but hopefully as we go on in this lecture today, that'll become more apparent. But any questions so far? Okay. All right, so now we're going to talk about vector multiplication. So this is not going to be an element by element operation. This is some matrix operation. So a vector is a type of matrix. It just either has one row or one column. So you can kind of think of it like that. So maybe you've done a dot product, either in your math class. So if you took Calc 3 or you're taking it now, you're probably doing this quite a lot in the beginning of the semester. Or maybe you're doing this in, your physics class too. I can't really remember.
Physics.
Yeah, you took it then in physics?
Yep.
Okay, cool. So all of you should be familiar with the dot product then. So if we have two vectors, u and v, and we do the dot product between them, it's defined like this here. So we have u dot v, that's going to be equal to u1 v1 plus u2 v2 plus u3 v3. It's going to have multiplication between each index in that vector, and then it's going to add them all, and our result is going to be a scalar. So we have two vectors here, but the result in the end is going to be a scalar. So it's going to be one value. And just for review, I, j, and k, here they're just unit vectors. So, this is good to know, but this isn't really, a physics class. It's a Matlab class. But we'll see here, if we have this multiplication here between two vectors, it's the same as the dot product that I just showed you. So we have a vector u, it's a row vector. It has values u1, u2, and u3. And then we have a column vector v, so that has values v1, v2, and v3. If we carry out matrix multiplication on this, and we're going to get u1 times v1 plus u2 times v2 plus u3 times v3. And then we're going to add all of that together, and that's going to give us a scalar. Let me go through my slides. Okay. So what I want you to take note of for this vector or matrix multiplication is that our size for the u vector was a 1 by 3. So we have one row here and 3 columns. For the column vector, that size was a 3 by 1. We had 3 rows and 1 column. Maybe not all of you know this yet from your math classes, but so I wrote it out here, and just to kind of show you what the result will be. So looking at the size of our arrays, that's going to let you know what the output is going to be, what the size of the output is going to be. Or if you can, do this multiplication. So we have an array that's a 1 by 3, and we have another array that's 3 by 1. So you see these two inside numbers, they match. Because they're both 3, or they're the same number, we can carry out this multiplication between these two arrays here. And these outer numbers, we have 1 and 1. That's going to tell us the size of the output that we're going to have. So because it's 1 by 1, that's going to be a scalar. And as we go through more examples, if you're not familiar with this, this will, start to make more sense as well. So, in my opinion, it seems kind of weird that you guys take this class before linear algebra. At least that's not a prereq for this class. And, a lot of this class is on arrays. So to me, that seems kind of strange, but whatever. I know some of you have taken linear algebra, but most of you are freshmen and sophomores, so you may have not taken it yet.
Yeah, most of us learned this stuff before the linear algebra class.
Oh, really?
Actually. Yeah.
In what class?
Basic, either Calc 2, I believe, or maybe even the tail end of Calc 1, and we start trailing into it.
Okay, I don't remember doing that, but maybe I did. But that's good. Good to hear. Okay, so hopefully, for at least the vast majority of you, this is just review. Okay, so let's actually carry out one of these operations now. So let's define a row vector, and of course, like always, I want all of you to follow along in Matlab so you can learn better. So let's define this row vector u into 3, 0, 7, and negative 5. Oops, negative 7 and 5. And then we'll define a column vector v that's 2, 1, 7, and 3. Okay, so if we look at our row vector, we have dimensions 1 by 4. So we have 1 row and 4 columns. And then for our column vector, we have dimensions of 4 by 1. We have 4 rows and 1 column. So if we were going to do this multiplication for u times v, we have 1 by 4 times 4 by 1. The numbers on the inside, they match. And then our outer numbers are 1 by 1. So that's going to give us a scalar. So if I do a equals u times v, then our output is negative 28. So that's doing 3 times 2 is 6, plus 0 times 1 is 0, plus negative 7 times 7, that's 49, plus 5 times 3 is 15. And then if we add all of that together, that's going to give us negative 28. Okay, so what if we change this to, instead of u times v, we change it to b equals v times u. Okay, so now we have an operation of 4 by 1 multiplied by 1 times 4. So we have 4 by 1 times 1 by 4. So our inner numbers, they match, and the outer numbers are 4 by 4. So that's going to give us a 4 by 4 matrix. Sorry, I put 16 by 16 here. It's not a 16 by 16, it's 4 by 4. So here we have 4 rows, and then we have 4 columns. I don't know why I was probably thinking 4 times 4. Okay. So this multiplication, I kind of outline it here, but this will be something that you should just know from math class, or you can kind of look at the slides yourself and kind of go over it on your own when you have time after class. Okay. Any questions so far?
So, Professor, so when you do the opposite, it multiplies the numbers from the row by each one number from the column?
I'm not exactly sure what you're saying, but basically, so we had 2 different multiplications that we did. So we did u times v in one operation, and then the other we did v times u. So yeah, we have the same vectors that we're multiplying, but the order matters basically. So when we did u times v, we had this. So it was 1 by 4, that's u, multiplied by the vector v, which was a 4 by 1. So because of that, we look at those 2 outer numbers and we see it's 1 by 1. So the output is a scalar. But if I change that order, to v times u, then the outer numbers are 4 by 4.
4. Oh, okay. So it all depends, like the number that's at both ends of.
Yeah. And
Okay.
that's, of course, assuming that those inner numbers, that they're the same. If they're the same, that means you can do that operation.
Okay, thank you.
So those inner numbers are different, then it's going to give you an error. So let's change this to u equals 3, 0, negative 7. Now if I do u times v, then it says incorrect dimensions. They need to be the same. So we can't do it. Or it's going to tell us, hey, maybe you wanted to do an array operation or element by element operation. And then it says to put a period, but we're going to, again, as I keep saying, we'll talk about that a bit later. Okay, so now we have vector matrix multiplication. All right, just checking the time because I want to, hopefully get to array division as well. Okay, so we have vector matrix multiplication. So in 250 for EGME 250, or actually not EGME, it's math 250B. Yeah, that's linear algebra and differential equations. You'll be solving linear systems pretty often. We're not solving one here, but you'll see that it's in this kind of format here where you have a matrix on the left and you have a vector to the right of it, but that's just an aside again. So we can multiply a vector by a matrix or a matrix by a vector like we have here. So let's do this right now. So I had a lowercase a here. I should have put a capital A. Because for matrices, we usually define those with capital letters. So let's define that matrix. So we have 2, 5, 9, and 7. And I want to show you the output. Okay. And then we have a column vector B, that's 3 and 4. Okay, and then we can multiply this. So let's first think, can we multiply it? So here on the left, for this matrix A, we have a 2 by 2, and then the column vector is a 2 by 1. So those inner numbers here, they match. So we can do the operation, and then the outer numbers, that's 2 by 1. So that's telling us that our output should be a column vector that's a 2 by 1. So if I do A times B, and that's what we get. We get a column vector that's a 2 by 1. And then here, I'm showing you the actual math that's kind of happening behind the scenes. So we do 2 times 3 plus 5 times 4 Then we have 9 times 3 plus 7 times 4. But again, that's more for your math class where you actually have to show your work, but it's of course good to understand what's actually happening, kind of behind the scenes. Okay, so we kind of touched on this topic with when we were multiplying our vectors u and v, and 2 slides ago or something like that. So let's show this again. So now instead, if I don't do a times b, but I instead do b times a, that's not going to work this time. So I have a 2 by 1 column vector, and then I have a 2 by 2 matrix here. So if we look at if we kind of write this out here, we see that our inner numbers, they don't match. So because they don't match, it's not going to be able to work for us. And it's going to say, hey, I can't do this. The dimensions, they don't match for matrix multiplication. So we can't do it. All right, any questions?
Can you go back one slide so I can see how they added? Yeah, thank you.
Yeah, sure. So, yeah, again, I'm not going to test you on the math, but it is good to know what's happening behind the scenes so you can actually understand why these operations are working the way they do or why they aren't working. So yeah, that's why I included some of the math here. Okay, so I'm gonna continue on now with the slides. Okay, so now I have an exercise for you. So I want you to solve this in Matlab and think about if we even can solve this before you get started. So we have a row vector, that's 2 and 5, and then we have some matrix here. And I want to multiply the row vector times that matrix. Okay, so I'm going to go over it now. I think that should be a pretty quick exercise. So let's define a row vector x. So let's say x is 2, 5. And then we'll define our matrix. So let's use a capital letter here. I'll define this as A. 4, 7, 4, 7, 2, 3, 0, 3. And then we're going to carry out that multiplication. So I want to do x times a. So here we have a 1 by 2 row vector, and then we have a 2 by 3 matrix. So those inner numbers, they match. We have 2 by 2. And then our outer numbers are 1 by 3. So we're going to have a row vector. We have 1 row and then 3 columns. So if we do x times a, then we get a row vector. That's 1 by 3. So here, I guess I didn't show the math, behind the scenes, but you can work through it yourself using the logic from some of the past slides or look in your math book or your physics book, whatever it may be. Okay, let's also now try a times x. So that's not going to work because this time we have a 2 by 3 multiplied by 1 by 2. So those inner numbers, they don't match anymore, so we can't carry out that operation. All right, matrix multiplication. So we can use basically the same kind of definition that we've been using to multiply matrices with each other. So more explicitly, I defined, if we can do an operation or not. So if we want to multiply a matrix A with a matrix B, the number of columns in matrix A, they need to equal the number of rows in matrix B. So this is what I've been talking about pretty much the whole class here. But we'll see that the matrix for matrix A, those columns need to equal the rows of matrix B. So that's N and M here, those inner numbers. And then our output is going to be these outer numbers, like we've been discussing. Okay, let's go on. So let's work through this exercise right now. So we're doing multiplication between two matrices A and B. So we'll do A equals 6, -2, make a new row here, 10, 3, 4, 7. Then matrix B is 9, 8. New row, -5, 12. All right, so can I do the multiplication of A times B? So we always want to think about this before we carry something out. So we have 3 rows, 2 columns. So we have a 3 by 2, and then here we have a 2 by 2. Those inner numbers, they match, so we can do it. And then our outer numbers, they are 3 and 2. So we're going to have a 3 by 2 result, which we see right here. So if I do A times B, then we get that same result right there. And this time I do show you the math as well. Okay, so what about B times A? So B, that's this matrix right here. That's a 2 by 2. If we multiply that by A, that's a 3 by 2. Those dimensions don't match, so we get an error. So so for our array multiplication, or I guess I should say matrix multiplication rather, we need to be sure that the sizes are the same, or not that they're the same, but rather that those inner numbers, that those are the same. The size does not have to be the same. So look, if I do size of A and size of B, they're of course different, like we have been talking about. So the size of A was 3 rows, 2 columns, and the size of B was 2 rows and 2 columns. Okay, so here are the properties of matrix multiplication. So it's associative. I spelled that wrong. You know what I mean though. It's distributive, but it's not commutative. So that's what we've kind of been showing right now. We could do A times B in that previous slide, but we couldn't do B times A. All right, let's see. Okay, so now we're going to go over array operations again. So just to kind of recap, last class we briefly went over array operations, even if it wasn't explicit. So if we had a row vector U that had values 3, 0, 3, and we multiplied it by some scalar 2, that was an element by element operation. It wasn't explicit, but it was multiplying each element in our row vector by 2. And today we went over matrix multiplication. And now we're going to go back to array operations. Okay, and someone asked earlier, can we multiply or divide matrix by matrix? So we just went over multiplication. Division is different, so we never use right-hand division for matrices. We will do array division, so that's going to be element by element. But matrix division, we don't really do. We do a left-hand division for matrices. That's when we're solving a system of equations. So, but we don't do this. So we usually don't do that, but instead we'll do A times B, and that'll be for solving a system of equations. Okay, so I just wanted to touch on that. Okay, so we're going to go over array operations now in more depth. We're going to be more explicit about our element by element operations. Okay, so we're going, between arrays. Okay. Okay, so, I guess recall a numeric array. That just means a collection of numbers. So that can be a row vector, it could be a column vector, or it could be a matrix. So just to kind of refresh yourself on the term array, that can mean any of those three. Okay, and then for Matlab, element by element multiplication is only defined for arrays that are the same size. So you'll see later on if there really should be a little star there because some things have changed between Matlab versions. So if you read through the book, it says this, it states this in the book, they're only defined for arrays that are the same size, but you'll see later that that's like a half truth. Really, I should amend this statement to say that element by element multiplication in Matlab is only defined for arrays that are compatible sizes. And I have an exercise to demonstrate that later on in the slides. Okay, so our definition here, if we have for element by element multiplication, if we have a row vector x and a row vector y, each having n elements, the product between the two is x, and then you see here I put a dot. That's to signify an element by element operation, times y, that's going to give us x1 times y1, comma, x2 times y2, and then so on and so on. So this is different, than the dot product that we had before. So maybe at first glance it looks similar, but it's different because we're not adding all of those elements there. So when we did the dot product, we looked at each element in these column vectors. We did u1 times v2, or sorry, u1 times v1, and then we did plus u2 times v2. Here, we're not doing that. They're separated still by a comma. So we're not adding everything together. Okay. So let's do an example here. So we have two row vectors. Sorry, I have a lot of typos. I was working on these slides late last night, so this is supposed to say inner. I don't know how I missed two N's, but that's supposed to say inner. So if I remember, I'm going to fix this slide after class. So we have two row vectors, A and B. So let's do that. A equals 2, 2, 4. B equals 3, 3, 3. Okay, so let's try. So I said vector multiplication, that's going to be the same as saying matrix multiplication. So let's try it. If I do A times B, that's not going to work this time because what we have here is two row vectors that are of size 1 by 3. Those inner numbers, that's supposed to say inner, they don't match. They're different. I have 3 and I have a 1. So because they don't match, I can't carry out this operation. So I think this will be a really good slide to contrast matrix multiplication with array multiplication. And remember, array multiplication and element by element multiplication, they mean the same thing. So they're different words, but they mean the exact same thing. So let's try array multiplication on this now. So I'm going to put a dot before the multiplication sign. And now this is going to work. So it's like our last slide here. We're going to do this index by index. However, we're not adding anything. We're just doing it index by index. So I'm doing 2 times 3. And then I'm going to the next index now. Then 2 times 3. And then 4 times 3. Okay, so that kind of contrasts those differences between matrix multiplication and array multiplication. Okay, so now I have an exercise for you that I want you to work on. So here we have two column vectors, u and v. So if we tried matrix multiplication between these two, that wouldn't work because we have two column vectors of size 3 by 1. Those inner numbers, they don't work. So let's try element by element multiplication or array multiplication. Think about what the output should be on your own and carry this out in Matlab. And then we'll talk about it. All right, so hopefully you're done by now. So let's do this. So we're going to define our column vector u. That will be -5, 2, 10. Then our column vector v, 5, 1, 10. So matrix multiplication, that's not going to work, remember? So if I tried u times v, not going to work because of our dimensions here. Those inner numbers, they don't match. So let's try element by element multiplication now. So u dot times v. So, I just said dot, but remember, this is not a dot product. It's array multiplication. And then we get output now. So we're multiplying our two column vectors here for each index. So for index 1, we have -5 times 5, that's -25. We go to index 2, we have 2 times 1 is 2, and then the last index, 10 times 10 is 100. All right, any questions? My stomach is growling. I don't know if you can hear that. All right, move on. Okay, so we have another exercise. So in the chat, basically, tell me if you think, without looking at the next slide, is this element by element multiplication, is this going to work? Okay, we got 2 no's. There's a lot more than you than 2 people. Okay. All right. So all of you are coming from a place that's solid, Okay. I like the comment. So let's go back in our slides here. Okay, so in this slide here, I said element by element multiplication. Okay, yeah, is only defined for arrays that are the same size. So those arrays that I just showed you, they're different size. But I also told you they should really say it's only defined for arrays that are of compatible size. So let's go back to our slide here. So, now you see the answer here. It does work. So this might depend on your Matlab version. So you can try to carry this out on your own, but let's define this right now, and then I'll talk about it. So we'll do a column vector here. X is 2, 4, -5. And then a row vector, -7, 3, 8. And then if I do X, we want array operation or array multiplication. So I get an answer here. So I actually first want all of you to do this on your own computer. And then, hold on. Okay, so I'm putting a comment in the chat just to show that I'm breaking it up. Isn't it -8? So you got -8? Either way, I want all of you to put this in MATLAB right now and tell me if you get the same output that I do, or tell me if you get an error. All right, so you got the same as me. All right, okay. So yeah, most of you are probably on the same version of MATLAB as I am, but if you go through the book, it's going to say that this should give you an error. And y. So let's do size of x and size of y. So the sizes here are different. For size of x, we have a 3x1 column vector. So we have 3 rows and 1 column. For y, we have a 1x3 vector. We have 1 row and 3 columns. So the sizes are different, but this still worked. So that's why I would rather say the word compatible. That array multiplication only works on compatible arrays. So they're different sizes, but they're compatible because we have these common numbers of 3 and 1. So it works now, but in a past version of MATLAB, I think back then it was like 2017 or maybe even 2016, I forget. This didn't work, but now it does work. I guess I didn't show you the what it's doing, but here, if we look at it, we're doing 2 times -7 is -14. And then, so we're kind of carrying out our, well, this isn't a great way to look at it, but 2 times -7, that's -14. And we have 2 times 3, that's 6. And then 2 times -8, that's sorry, I had to find something a little different. Yeah, I have a 2 here. Oh, I put a +8. I always do that. I always forget to put a negative or positive. But you can kind of go through it here, looking at the slide, and you can see how it's doing that array multiplication. So it is defined for us now in this version of MATLAB, but past versions of MATLAB, you'd get an error. So there's something to kind of watch out for. Okay, let's see. So if I do x times y, so I'm doing matrix multiplication, that's actually the same thing. So this operation is the same thing. I thought I put this in the slide. Maybe it's a different slide where I say that. But yeah, so basically this is going to be the same as doing matrix multiplication. So I have a 3x1 matrix here, and then I have a 1x3 matrix here. Those inner dimensions, they match. And then our outer dimensions, that's 3x3. So our output is a 3x3 matrix. Okay. I kind of feel like a lot of these slides today might be a lot to take in, at least if you haven't taken a math class that goes over this stuff. So I would really recommend that you look over the slides after class or, sometime this weekend to really understand it.
I have a question.
Mm-hmm.
Would any matrix operation also work with element by element?
No. So we should probably have that later on here. But yeah, some of the matrix operations, they won't work for element by element. So for that, you can kind of, look at the slides that we have in the class and see if both of them work, but they won't always, both work.
Okay.
Yeah, so I might have a slide on that later on too. Okay, okay, let's do this here. All right, so let's go through this exercise here. So let's define these two matrices. So we have A equals 2, 2, 2. Then we have 9, 9, 9. And then we have matrix B, that's 0, 0, and then 3 and 3. So I'm going to show you the sizes. So we do size of A and size of B. So now these are different sizes and they're not compatible because they aren't sharing those same, numbers for the rows and columns. So here, if I do A times B and I try out an array operation or array multiplication, Now that's not going to work. It's going to say our matrix dimensions must agree. So that doesn't work. Okay, so Fabiola, I think you just asked about if a matrix operation would work and an element by element operation wouldn't work, right?
Yeah, like
Okay.
if it's a matrix, would it always work for element by element?
Okay, so this is a little different than what you just asked, but here the matrix, the array multiplication didn't work because our matrix size was different. But if I did B times A, then that is going to work. So that's matrix multiplication right there. And that did work for us because we have a 2 by 2 matrix right here, matrix B, multiplied by matrix A, which is a 2 by 3 matrix. So that's going to give us an output of 2 by 3. If I did A times B, that's not going to work. Remember, the order matters because our sizes are incompatible. So that's a little different than what you asked, but putting it in the way that you asked, that might happen too, where it doesn't work. I'll need to kind of sit down with you after class or something like that, and we can go through it.
For that one, what if you put B dot and then times A? Would it work?
It shouldn't work because they're still different sizes. So remember, for array multiplication, the sizes have to be the same / compatible.
Okay.
Yeah, so here we had a size of 2 by 3 for matrix A, and then for matrix B, it's a size of 2 by 2. But if we go back to the previous slide, so we had a size of 3 by 1 for X, and for Y, we had a size of 1 by 3. So those are, I'd say, compatible sizes because we have the same numbers here for the rows and columns, but they were just kind of inverted or transposed. All right, so compare array matrix multiplication. All right, so let's do this right now. So here, both of them are going to work. So kind of going back to what you said, but maybe still not the exact answer you want. So let's define matrix A. So we have A equals 10, -5, 0, and 5. I want to show the output. I just by habit, I always put a semicolon to suppress the output. And then B equals 2, 6, -6, 8. All right, so doing matrix multiplication, this is going to work for us. We have a 2 by 2 and a 2 by 2. So our output is going to be 2 by 2. So if I do A times B, we get a 2 by 2. And then array multiplication, our matrices here, they're the same size. So that's going to work for us. But the output for array multiplication is different than matrix multiplication. So this is when it's important to know what's happening behind the scenes in Matlab. So I'm showing you the math operations here. So you can go through that and you can see that they're different. So remember, array multiplication, that's carrying out whatever operation we're trying to do for each specific index in the matrices. So we're going in position 1 for each matrix, 10 times 2, 10 times 2, and then for position 2, -5 times 6, and then so on. Okay, so here, yep, both of them worked, but the result was different. All right, so we basically are running out of time. So here I go over element by element division in slide 85. I think this is a question on the homework, so look at this slide. I'm going to keep it on the homework because it's still simple. It's just doing this division for each index in these vectors right here. So just make sure you look at the slides for whatever question this is on the homework. it works like multiplication, but instead it's for division now. Okay, so if you have any questions, stay after class. But does anyone have any questions right now that I can answer before we finish? All right, so just some reminders. Homework 2, that's due this coming Monday by 11:59 p.m. Quiz 2, that's next Wednesday. We'll have that at the end of class. The difficulty should be around the same as quiz 1 was, and the time is going to be the same as well. I'm going to give you 15 minutes to work on it. And it's only going to cover everything that we covered in today's lecture and, past lectures. So we stopped on this slide here. We stopped on slide 80. So nothing after this slide will be on the quiz. You do have that one homework question for array division, but that's not going to be on the quiz. All right, so that's all I have. So you guys are free to go, and I'll see you on Monday. But if you have any questions, then stick around.
Thank you, Professor.
Yep, thanks, guys.
Thank you, Professor.
Thank you. Have a good weekend.
Professor, is there a way I can share my screen? Because I don't have the workspace on my Matlab. I don't know if
Yeah.
I probably clicked something that allowed it to like disappear.
Okay, yeah, we'll wait a few minutes just in case anyone else has a question,
Gotcha.
and then I'll allow you to share the screen.
Okay.
I have one more question. Can you explain how A times B was multiplied?
In this slide here?
Yeah.
Okay, so you're saying for matrix multiplication or for array multiplication?
Matrix.
Okay, yeah, so did you take 250B yet?
No.
Okay, so yeah, it's going to be a little weird at first. So I actually had to review this myself last night because it's been a while since I did this.
Okay.
But basically, we have two matrices, A and B, and we're doing matrix multiplication. So we start out by looking at our first row here in matrix A, and then our first column here in matrix B. So we're doing 10 times 2, and then plus -5 times -6. So that was that first row in matrix A, and then the first column in matrix B. Then we're going to look at the first row in matrix A and the second column in matrix B. So we're doing 10 times 6 plus -5 times 8. Does that make sense so far?
Yeah.
Okay, and then we're going to look at the second row for matrix A, and then the first column for matrix B. So we're doing 0 times, did I say second? I meant first. So second row of matrix A and first column of matrix B. So we have 0 times 2 plus 5 times -6. And then we'll look at the second row of matrix A and now the second column of matrix B. So 0 times 6 plus 5 times 8. So on the top left here, we have first row of matrix A, first column of matrix B. And this spot right here, sorry, we have the first row of matrix A and the second column of matrix B. In the bottom left here, second row of matrix A, first column of matrix B. And then the last spot, second row of matrix A, second column of matrix B. So yeah, since you didn't take that class yet, it's probably looking a little weird, but if you kind of go through this video again, so I'm going to upload this later today, you can kind of, play it back and kind of go through it, and then it should make some sense.
So it's basically like grabbing B and putting it on top of A like sideways and multiplying like that.
Yeah, I guess you could think of it like that, but yeah, I'll just, go through it how I just talked to you about it, or if how you just said it, if that's easier to understand it that way, then you could think of it like that too.
Okay, thank you.
Mm-hmm. All right. Any other questions? Oh, where'd Josh go?
I do have one, but let him finish first. I will go after.
Okay, well, I think Josh left. I don't know why.
Okay.
Yeah.
Okay,
All
so,
right, so what's your question?
okay, so I have a question about the last quiz.
Okay.
And the question that asked us about the function input.
So I'm gonna share my screen just so I can go over it with you. Oh, it's already being shared. Okay, let's go to the quizzes. Okay, which question is it?
The function input, I think the one with the sine x thing.
This one?
Yeah.
Yep.
So for me, I put the like a different format, but it works like after I tried it like last night, and it worked on my computer.
Okay, so here, what I'll do is I'll talk to you once I address everyone else here, so we can kind of go in our own room, and then
Okay.
I'll go over your quiz with you, and then we'll check it out. I may have
Oh.
graded it wrong, because
No
yes,
problem.
sometimes
No
I
problem.
make mistakes too. So okay, so yeah, I'll talk to you. Stay in here, and then I'll address you in a few minutes. So
Okay.
okay, Josh, so you're back. I'm gonna allow you to share your screen.